Okay. Trying to get out from behind there, are you? She always she can't resist making an appearance, folks. Hello out there, everybody. Yep, she's kind of in there. You could peek your head in, say hi, whatever. A little better than that. Get over here. Never fails, never fails. Hello once again, everybody.
Hello.
Welcome. Everybody's here in some capacity or whatever. Although some people
doing
like
magic tricks.
What? Exactly what tricks?
A lot of magic tricks. Magic tricks.
I'm not even sure I want to know.
I made some coins appear from behind his ear.
Or so you think.
Anyway.
All right. Well, anyway, good to see you guys again as we begin another week here with these live streams here at Learn Math with me, Brian Sapinski, and with Brianna and everybody else. Okay. Hopefully you guys know how to do this or whatever. Okay. The live chat is waiting here underneath. I'm just making a reminder to anybody that wants any suggestions, anything you want to know in the K-12 math spectrum, please by all means, submit your suggestions right there and everything. So hope to get some ideas from you, or if you want, you could also, like said, send it as I've asked to do. If you can't send it the old way, okay, Brian.Sapinski. Get my I in there at gmail.com. Okay, you know the deal there too. So just come on in and join us. Anything you want to know, we're here. Okay. Now to start today's off or whatever. Over the weekend, had a a student of a friend's who wanted some help on a couple of things. Oh, you're telling your friends that we're in there. All right, tell them if it's not immediately working. Check, they may have to right click on the video link or whatever, and then say like open in a new tab or window or stuff like that. It might work that way better. So who knows? Okay, but I'm gonna challenge you a little bit because I want to base something on something that, like I said, one of mommy's friends was.
At the end, can I show them something I made?
All right, show.
It's this.
Okay. No, that's not for here. Come on.
Come on.
No. Come on.
Fun.
Don't get crazy. Come on. No, you got your own thing for that. All right. Here, I need to challenge you a little bit. All right. So I need you to follow this. We haven't done much stuff with exponents. Okay. I know you're aware of that. Okay, but I want you to follow me on this. Okay. Try to understand something that's going on here. Okay. Now you know in general how exponents work, though, right? So when you see something like this with 10 squared, okay.
100.
Okay, because how does this read the long way? How does 10 squared read the long way?
10 times 10.
Right, that would be 10 times 10, which you're right would equal 100, right? So on like that. So if you saw 10 to the third,
10 times 10 times 10.
Okay, which in this case would be we know 2 tens is 100, so what makes 3 tens? 1,000. Okay, right. All right, so you got that. Okay, so you have that going and stuff like that. All right, so with that in place, all right. So you know in general how the exponential rules going that way. Now I want to turn the tables on you a little bit. Okay. Now, what if I wanted to know this? Sorry, now I'm gonna pick another number here and stuff like that. All right, let's say I use 2 for instance. Suppose I were to tell you that I want to take the number 2. I wanted to raise it to some exponent, okay? And the result of that was, let's say 8. Okay? So you recognize that, like you said a minute ago, with the exponent, that represents, that you have to multiply the base a certain number of times over to get to a specific product, right, Bria? So here's my question to you. When you see this, the thing you want to try to answer is how many times 2's do you need to get to 8? Okay? So how many factors of 2 do you need to get a product of 8?
4.
Well, wait. So you're saying that 2 times 2
No, wait,
times...
3. 3.
Okay.
Because it's 2 times 2 is 4, and then 4 times 2 is 8.
Yeah, okay. What mistake did you make? Because I see a lot of people make the scoop.
2 times 4 equals 8.
Yeah, that's something entirely different. Yeah, a straight multiplication is not the same as an exponent, folks. So you have to be very careful about that. So yeah, because what you were thinking of effectively was for what you were thinking of plus 2's, not times 2's. Remember, we've been talking about that fancy do this and recognize that this is the third 2 in the system. So that would mean that the x would equal 3. Okay, now. So okay, and here, let me do another one of this because I want to make sure that this is understood. Hello to whoever's joining us. You want me to do a topic? Throw it in the live chat there. Okay,
yes.
Here, let me show you another one. So what if, follow this with this one.
Okay.
What if I wanted 5 to some power and I wanted to get to 625? See how many times 5's it would take to get to 625.
5 times. So that's 2, 3, 4, 4.
Okay, 4. Yeah, because you had 5 for the first one. The second one gave you, well, you did times 5. The second one gave you
5, 25.
25 times the third 5 gave you
125.
And then the fourth 5 gave you 625. Yeah, get a counting list going for yourself. Just list out what the next times 5 times 5 times 5 or whatever the base is. List it out so you can see where in the string it gets you to. That's part of the whole fancy counting setup. So since it happens on the fourth one, that would mean that x equals 4. Okay, now I wanted to show you that, Brianna, because here's what the daughter of one of mommy's friends came to me and was asking about. They were having trouble with a certain type of sentence. Now, this is going to be, you're not going to see this for several years. Okay, I'm just giving you a forewarning about that. But there's going to be some things here that we could still do with it that are simple enough in design that I want you to demonstrate. Everything we saw here in trying to get this this x up here, and the same can happen in these sentences as well. There's a sentence in higher order algebra that summarizes all the information here. It's what's known as logarithms. Okay, yeah. So this sentence, that's these two sentences that are here. Here, I'm just gonna take away the 3 and the 4. Watch this, Brianna. This sentence that's right here.
Yeah.
These are what are referred to as exponential equations. Okay? Now here's the same sentence in what is called a logarithmic. Logarithmic. Who's gonna remember how to spell it? Okay, here's how these look. Same information. Watch this. First, the abbreviation for logarithm you have, obviously it's going to be the word log. Okay? Log 2, 8 equals x. Okay, well, all right, just hang on with me for 1 second here. Okay, so that exponential sentence, everyone likes, I heard what you said, give me a minute. Okay, and then this one, so now here's the translation of it. So follow this. You see the 2 at the bottom, right? That 2 represents, in an exponential equation, that's the base. That's the base that you're starting with. So this tells you what multiplication you're counting by over and over again. The 8 that's here next to it, That's the end result of the calculation. So the idea is that this is the base. This is the result.
Could you also divide it?
And this is the exponent.
Could you divide it?
No, wait. Well, understand. Divisions can be translated into multiplications.
Like something small like this.
Okay, it gets into a little something in the other direction. That's where you get into like the almost sort of the negative exponent concept. But that's we're not going to talk about that right here.
Huh?
No, don't even worry about it. Just throw that out of your head. So anyway,
look, there's someone else.
Okay.
If you have a topic, put it in the live chat.
Keep submitting. Yeah, submit those topics into us.
We're doing
a little higher end stuff in the moment, but I'll do any level K-12 that you want.
Random equation.
Throw in that live chat.
Or maybe just say hi.
Yes, say hello first. Yes.
Just say
Let
hi.
us know who you are. Okay. All right. So here's what I want you to do. Here. So you see how this all right. So you see how this translates to this. Okay. Here, you try to translate this one. Make a logarithmic sentence like this one that use it. So where I use that to make this sentence, you take this information and translate it into a logarithm. Let's see if she can do this. Let's check. It's out of the way for you.
There.
Okay, you just forgot one little thing. You left something out.
Oh, the 2.
No, not 2. What's your base? The 5. Right. Yes. Okay. That's how that would be. Exactly. That's exactly what.
Oh my gosh. No.
Chill yourself. Relax. Stop at the screen. Stop. Come on. Chill yourself. Okay, that's how it go. Yeah, because this is actually important, Brianna, because this is an important thing. The problem that exists here is that if you forgot to write that 5,
we wouldn't know which one.
Well, actually, there is a thing. When the log is written just by itself with no number underneath it, it's automatically assumed when you just write log that the number down here is a 10. That's the automatic given. That's what's referred to as the standard logarithm. Okay, that's how essentially that goes. But you wrote it exactly correctly, so that's the way you want it to read. So these were the kind of sentences that Mommy's friend's daughter was working with on over the weekends and came to me with some help about. But the things that this student had to do went a little bit past that. Okay, because now you see how these logarithmic statements read, right? Okay, so here's the kind of stuff that
This is the Smiley's pet rat.
Okay, I'll let you get away with that one.
Because I want to show you. Because I want to show him something. But you said I can't. So.
Yes, no, don't get started. What and what?
Oh no! Oh,
No. That's something with my camera. That has nothing.
Something on iron?
No. That's okay. If it's for some reason this laptop's webcam, I don't know. Every once in a while, over the last couple of weeks here, right? I just want to. Let's see if that's it. Okay. Or I guess not. I'm still here. Don't worry. We're still here. We're still moving. It has nothing to do with the feed. It's just
you could kind of see it.
The camera's the camera in this laptop is just giving me a little.
Dad, you could kind of see it.
I know. It's giving me a little fritz for some reason. I don't know why.
I'm sorry that you guys can see it. Hey guys, please say hi.
It's the camera. Okay, so
hey guys, please say hi.
Okay, where did I put the markers at? Okay. But no, I had a different. Okay. Oh, there it is. Okay. So sorry. All right. So now you remember the logarithmic sentences that we just saw. Okay.
Yes.
You remember we saw.
Yes.
Okay. So here's what our student friend had to do. They were dealing with trying to simplify sentences that looked like this. Okay. Take a look at this. Okay.
Mm-hmm.
Now I'm just throwing this out. Okay, I'm going to base it on the ones that you saw. Okay? So follow this.
Uh,
So here's the cat. Oh, geez, clouds are rolling in quick. We had I mean, it's cloudy out, but we had some. It was bright clouds or whatever, and I could suddenly tell the dip. I could tell the rain's coming in and stuff
we're
like
so
that.
sorry that it suddenly got so dark.
So definitely yeah. So we can tell the rain is coming, but it's not going to stop us. Nothing will stop us. You know. So anyway, so here's what happened. Okay, cool. All right, so here's the thing, Grant. So here's what she had to deal with. So a minute ago we had this. Now, okay. So if you go to calculate log,
do we need that paper?
No. So here's the thing. Okay, if you had to okay, wait. I need your help here. Stop. I need your help here for a second. Okay, so if you had to do this.
Oh gosh.
Oh yeah, now it's raining. Woo! Here it comes. Yeah.
This is like the depiction, unless if you can't hear
it. I think if you listen close enough, you could definitely hear it, because when it pours, which it is right now, holy. Up there, you need more proof. You know what? I think this is the first time we've done a live stream where we had any kind of a thunderstorm happening, where we actually got the thunder booming. I don't know. Did anybody watching hear it there in the background? Leave us a comment in the stream or whatever. Let me know if you could hear any of the rain behind us or anything. Or even if you're
watching it after, comment the thumbs up emoji.
They're watching after the rain. That's one for you, Andrea. A little Nelson. No. Wait. Understand something. No. Hear me out.
Look at what quarantine is making him do.
Wait a minute. No, come on.
He's going cuckoo.
No, come on. I would make those jokes regardless. But no. No, Mommy will understand that, because because when Mommy and I were growing up, there were a lot of rock bands that were known for their big hair and stuff like that. They were called they were called hair metal bands. No, not that kind of hair. No. Having like the long, super long hair and stuff like that.
This?
Look up no.
Like what Jesse had at the beginning of Full House.
No. Vaguely. Here, wait. I'll show you what I mean. Wait a minute. Hold on.
And then
we have these little diversions, folks. Okay, wait. See, like, oh wow, that's really correct. See, like, look at that.
Oh God.
See, that was what, like I said. This is like Bon Jovi back in the 80s. Okay, whatever. All right, yeah, like I said, that's what hair.
Oh, maybe that's what's causing it. Oh my. There's like.
That was a good snap. Did you see that? Did you see that flash?
Yeah, maybe it's because of the rain.
No. Again, my camera has been fritzing a little bit lately. No, that's nothing. No, the storm is not doing that at all. Okay, that has nothing to do with it. So don't ignore it. Okay, but let me get back to the point. No, one of the hair metal bands that was popular in the 80s was a group named Nelson or whatever, and they had a song called "After the Rain." Okay, it was Nelson, right, cutie? Just let me know.
Just press
okay, just let me know if I was right on that. Anyway, God, what the heck is going on with my camera here? I am determined to keep this going, folks. Okay, so but that was the joke I was making. All right, let me get back to the point. Okay, log of 100, Brianna. Follow me on this.
Mm-hmm.
Okay, so again, when you don't see anything, that means that automatically you assume a 10 right there. Okay, so how many 10s make 100? 2. Okay, so this would all calculate to 2 plus, okay, and then how many 10s make 1,000? Like you saw a minute ago. How many 10s make 1,000? 3. Okay, so you calculate each log, and so in the end, what is 2 plus 3? 5. Okay, now, what if I told you that there's a way to rewrite this sentence before you calculate it that would give you the same answer? Okay, here's the rule. Okay, why? Okay, yes. All right, and here this method of rewriting the
keep surprised.
Okay, all right. I got to move it. No.
Surprise
I
guy.
understand. Okay, I don't have the room. Give me a second. All right.
At least keep crying, guy.
No crying. All right.
But
So
it's because you're a surprised guy.
stop that. Okay. All right. So wait, listen. Stay with me.
Guy.
Stay with me.
You're
Okay,
a
fine.
surprised guy.
All right, fine. Enough.
Crying.
Can you let me talk?
Sad guy.
Can you let me talk here? Are you entertained yet? Okay, let me see. All right, so here's the deal. So there's a rule. There's a rule that when you see two logarithms that are being added together, that as long as they have the same base, there's a way that the sentence can be rewritten. It goes like this. The rule follows this general rule. Okay. So that if you have a log based on a certain base, and it's being added to a log of some other number, but from the same base, that would be the same as if you had a single log where these two end results were multiplied, like this, Brianna. Okay? You understand?
Whoa!
So here's the deal.
That was a big one.
So here's the deal with it. So if we apply this rule to this sentence up there, Brianna, okay, real quick on your calculator, multiply 100 times 1,000. Punch it in. Punch in 100 times 1,000. And it gave you what? No, it's not 10,000. That's how much?
100,000.
Okay. So since the 10 times 100 makes 100,000, okay, that means that's the log. Here, let me move that over a little bit. That's the logarithm that you would be calculating. So now you'd be calculating the standard log of 100,000. And then as it turns out, so what you would now be calculating, Brianna, is how many times 10s make 100,000?
That's 5.
It would be 5, yes, because look at the list. 10, 100,000. Take a look, Brianna. 10,000. And on the fifth one, there's 100,000. So yeah. So as it turns out, if you're able to physically calculate the two logs separately, then by all means go for it. Otherwise, you can multiply them together, convert it into one sentence, and get the log off of that and stuff like that, and different things based on that. Now, similar rules exist that we won't necessarily do them right now, Brianna, but listen, but the same. All right, yes, thank you. But the same kind of rules exist, Brianna. That like I said here, just real quick, where it's an addition here, we have the multiplications of x and y. If this had said minus, what would this say instead of x times y? If that was a subtraction there instead of an addition, then what would this say instead of x times y?
But that is subtraction.
No, but I'm saying before I had a plus here. And when there was a plus here, I put x times y over there. But if that said minus instead, that would mean instead of x times y, it would say x divided by y, right?
Dad, look.
It would be like this. So that conversion rule exists also. And then there's another one that's used for when there's an exponent on the number there, but we won't talk about that right now. But those were some of the kind of things that she had to do as part of her assignment, where she had to try to solve for variables in these logarithmic equations, but she had to do them through taking additions and subtractions and smushing them together like that. So that was the story. Kind of make sense?
Mm-hmm.
Okay, cool. So hey, giving you more that you'll be ready for in later years, and hey, so hopefully some of you out there may be going through it right now, but if not, something for the future for you. If you got something current that you want to, something that's more on your level that you want to see, throw a topic down there at the bottom. Okay, here real quick, go get some. Okay, enough. Go get some. Go get your drink. Go get your drink.
And this is because it was 100,000. So.
Oh,
Can I say it in the live chat?
Will you just go get your drink? You've been asking me for the. Never fails, never quits. That's okay. I love her. That's why I should. I hope you guys love and enjoy what we're doing too and stuff like that. In spite, I gotta figure out what the heck is going on with my camera. I have no clue what is going on here. I don't know if that did anything. I don't know. This thing is going nuts here. What is going on with that? Seriously, this is the glitchiest that this camera has ever been and stuff like that. I hope it's not bombing out or something like that. I need this laptop. This is my work laptop that I'm doing this off of, folks. Who knows? But while Brianna's downstairs, let me just mention something here. Wait, Brianna, bring your Chromebook up. Bring your Chromebook. I figure we might as well take a look at a couple of her topics and stuff like that or whatever. So, yeah, haha, yeah, it's over 9,000. Da da da. Okay. Okay, Cutie, since when down there from the peanut gallery, since when do you start getting into the Dragon Ball Z jokes? Oh, God. You don't even watch anime. But who's to say there? All right, so, okay. God, what in the world? I'm definitely going to have to, I tell you, folks, these quarantines and stuff cannot end soon enough, because if this thing's going to fail on me, I'm in trouble. Because this has been very strange how it keeps on fluttering in and out and so on like that business. But all right, so let's see what Brianna's going through in her stuff. Oh, she's finally getting into doggone decimals. Finally. No. Ugh. Yeah, this is, and again, this is gonna bother me. So who knows there? All right, okay. All right, we got some basics on place value and stuff like that. Okay, cool. I see it. I like it. I like it a lot. All right, so okay. Some things that you guys know with regards to decimals and place values and stuff like that. Let's get some basic rules for the numbers and stuff like that.
Dad, look. Look at it.
Okay, here's the deal. Was that you or mommy?
Me.
Oh, that was you. Okay. I was gonna say, mommy don't know that stuff. Mommy doesn't know that joke. I'm surprised you know that joke. You don't even watch Dragon Ball Z. Give me a break.
No, it's me and Joey literally got it from an X-Man game.
Yeah. Oh, that's in those games.
Yeah.
Oh, by the way, true fans of the show know that that's actually incorrect, that translation.
Right.
In the whole it's over 9,000 thing and stuff like that. No. Listen, no.
Because it's literally
you don't understand what I'm saying. No, you don't understand what I'm
over.
saying. Listen to me. You don't understand what I'm saying. Fans of the Dragon Ball Z anime know that that's how what they said when Dragon Ball Z was dubbed into English. They said it's over 9,000. In Japan, though, that it was actually misquoted. It was actually supposed to say 8,000. Why they changed it to 9,000? Don't know. Beats me. Okay. All right. Let's get back to business. Okay. Place values.
It's like the jelly donut debacle.
Place values with regards to decimals. Okay. Now, all right. Give me. Okay.
Donut.
All right.
Like, not the jelly donut. Yeah, I'll explain it later. Yeah, I'm gonna explain it later.
Okay. Yes. Place values. Okay. We know the ones to the left of the decimal. Okay. What is this?
The ones place.
Okay, that's the ones place. Okay, followed by
the tens place.
Okay, some of the more basic things that you learn.
The hundreds place.
Okay, and so on like there. Okay, but now you're really starting to get into the decimal business and stuff like that. Okay, so let's talk about these. Okay.
That's the 10th place, 100th place,
Okay, well, wait.
1000th place.
Let me get there.
10,000th place.
Okay. Now the thing. Now here's the key. Just leave it there. I'll have some of that. The thousandths.
I brought gummies.
No, it's not gummies. It's fruit snacks.
Sorry, it's just like me, Elisa, Maria used to always get these. Like, we always call them gummies instead of fruit snacks.
No, I understand. No, I get it. So here's the thing. So the reason why these decimal positions are referred to that is, what you're going to see is that in all the times you've ever counted, everything has always been based on a 10 must system when you talk about your digits, because like I said, when you count, you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then once you get to the next number 10, notice that the first digit in that goes back to 0, so you repeat the cycle over and over again. It's a 10-digit system.
Oh gosh.
Okay, yeah, I know. So
should we use my Chromebook?
So it's a 10-digit system.
Should we use my Chromebook?
So we'll talk about it later. So that's the whole reason for the placements there. Now the same thing happens when you start talking about decimals. There's still 10 possible digits from 0 through 9 that could go in each of those places. But coming after the decimal point, what that means is that those are translations to fractions or whatever. So like when you see the number 0.1 like this, okay, 0.1 is the same as saying the fraction 1/10, okay, because this is not a whole number. It's part of a number. The idea is you would need 10 0.1s. You would need 10 of these. I'm not going to try to. You would need 10 of those added up to get yourself back to one whole. That's the whole key behind it. So hence the reason why it's called tenths, because you need 10 of these pieces to make one whole. The same kind of thing would happen. The same kind of thing would happen over here. 0.01. Would you stop with that?
Can you?
Not right now. We're having enough problems here. Okay, the same thing here. When you see a 1 in the hundredths position, 0.01 like this, that represents you need 100 of these decimal position to get back to one whole. And 1,000, and if it's over here, 1,000 of these to get back to one whole, 10,000 of these to count 10,000 of those to get back to one whole, and so on and so forth. So that's the whole nature, but it's based on that 10-digit must system. Okay, that's the whole thing. What is it? What is it? Stop! No.
Please.
No, stop.
I'm embarrassed.
Stop. They get it.
No, because it's literally over 9,000.
Stop.
No, literally.
They get it. They get it. All right, but that's the whole point. It is behind that. So you're discussing right now what you're seeing there in your problems. Okay, you have some decimals that it wants you to try to translate some numbers with or whatever. So here, dig up the numbers and
can I explain the jelly donut thing
now?
No. Okay.
Come on. Let's get this in place here. Now I'm going to take with the numbers that you've got. Look on the worksheets.
Okay.
So now I'm going to take away the names now.
Exercises.
Get the Google Docs out. All right. So now here, you put the numbers in, and you tell me what the places stand for. You guys try it too out there.
So
Okay.
it's like it was some kind of sushi, but then they
Can you
changed it to
stop?
jelly donuts.
Stop talking about that.
Oh gosh, what?
Come here, put it in your lap.
I'm looking at it.
She's contorting herself to try to read what's on her screen.
Oh, good lord.
She's putting it behind her. All right, so put the numbers in the proper place.
2. Fine. You can barely tell.
Would you like to sit over here instead? Would you like to sit over here so you can reach it? Here, switch.
It's like one of those for captchas.
No, it's not that. Just here, switch with me so you can actually reach it. Yeah. Switch chairs.
I think there's even one that says giant bagel.
This is the first time I've sat over here during these streams.
There's actually one that a recaptcha that said giant bagel.
All right, so what's the what's the question you want to know? Okay, what is the place value of the 8 in this number? Here, I'll fix it here so you can read it a little better. Okay, because now, like I said, now I've eliminated the names or whatever. Okay, so look at the position. So it wants to know what's the 8. What does the 8 stand for?
The thousands.
It's the thousands, right? Because again, remember, like I said, think about it. One whole. If you take the decimal away, there's 1,000. So you need 1,000. You need 1,000 digits to run through this place to get to one whole. Hence why the 8 is in the thousandths position. Okay. So all right, here. While we got it, write that down. Write that down, and then you tell me what the next. You tell me the next number, what it says. Wait, okay. What's the next number say while we're waiting? While you're typing that in, what's the next? Read the next number.
Okay, 25.07.
25.07. Okay, and what's it want to know?
Digit of the 7, which is the 100.
Okay, it's in this position. Okay, because again, put yourself back at one whole. To get to one whole, you need 100 digits to go through that spot. Hence, right, it would be the hundredths position. And if it helps you, yeah, write it out that way. Put a 1 in that one whole position, and for whatever decimal place you're looking at, write out as many zeros until you fall right under it, and you'll see the number there. It will tell you exactly how to read each of the decimal places and stuff like that. 10, 100,000, and so on and so on. And I actually just came up with that idea right now on the fly here. So you're coming up with a Sapinski original. So I'll have to do this more formally later, if my camera lets me. What's the next number? What's the next number? Read it. No, stop with that. Go to the worksheet. I know what's there. No, it's something else, not the Dragon Ball Z thing.
It was something else. 1 point.
Good. Put it in.
Okay. 1.3. Oh gosh. I forgot it.
Don't worry, I have my moments too.
7.
You guys have looked at enough of my chicken scratch to know which digit they want to know about. They want about that. Okay. Put the 1 here. Yeah, but again, just to show it, put the 1 here. Put the 1 here. The one whole, and move it over. Put it under that plate. Okay. So that. And so there.
What?
And so there's the proof. Tenths. That means this is tenths. So the 3 is in the. So the 3
Surprise,
is in the 10th
make
position.
this comeback.
Okay, all right. Can you stop?
He looks crazier.
Can you stop? So that's how that place is there. Okay, will you stop? No, we don't need that right now.
No, it's not that.
What? What? I don't know what you're talking about.
Up there.
No. We're not doing any of that.
I'm confused.
I don't know what those are for. So those are the kinds of things that you're looking for on each of those. All right, so same idea here. Okay, so let's see. Okay, so all right, so the next one. Okay, so the next one we switch the question. No idea. Okay, so next one switch. So the next one switches the question here. All right, so now it wants to know, as you read these, okay, it gives you a digit, it gives you a number, and it wants to know, now instead of what number is in this place, now it's asking you what place is the number. You've got 2 worksheets there. So here's the thing. So here's this number. Okay, so now the question wants to know wait, go back to the other sheet. Go back to the other one. Okay, so the number wants to, okay, what number is in the 10th place? What number is in the 10th place?
9.
What number is in the 10th place? What digit?
0.
The 0 is in the 10th place, and then what digit is in the 100th place?
6.
The 6, right. Because again, like I said, here it is, 10, the 10th place, that's the 0. Make it 100, the 100th place, that would be the 6, okay? But yeah, always put the 1 for the 1 whole, put it underneath here, put it to the left of the decimal point. So this way you can read your decimal positions out properly, and so on like that, okay? Give me another number that's there.
Oh, this is a big one, I think.
Read it.
Oh, gosh, I really should it's over there.
410.528. Okay. All right. So, okay, they want to know about for this one. Okay. What's in the 10th place? What's in the 10th place? Okay. Yeah, because once again, here it is, like set. But what?
Yeet.
Away with you.
Be gone.
Yes. Okay. So once again, write it out, 1 whole, and a 0 afterward. There's the 10, so it's in the 5 position. Then they want to know what digit's in the 1000th place. So what's in the 1000th place?
8.
The 8, because again, stretch it out to 1,000 right there. There's the 8 right there to go from there. Okay, so that's what we get for that position. Just keep spelling it out for yourself like that, and it's very simple and straightforward in design. Where'd the rag go? Where'd the rag go? Where's the rag? Where's the root beer rag? Look behind. Oh, it's down there. Down there, right to your side there.
Yeet.
Okay.
No, not surprised, guy.
Okay,
Please.
come on. Don't get, what do you call it on me?
I'm getting attacked. Where's the truck?
Give me another one.
Okay.
Give me another one.
Okay. Oh, this is we need to make one more space.
One more space?
On this side.
Ooh. Okay.
Because
what's the number say? What does it say?
3 points.
You sound like Hannibal Lecter there.
Huh?
You don't want to know.
Then why did you say it?
The adult audience out there will know who that is.
The one person watching.
Maybe. Read it out. What's it say?
3 point.
Yes, go on.
74195.
Okay, so before we go any further here, we had to add that extra decimal place, that one all the way at the ends. Again, we already know that this is tenths, hundredths, and so on, okay? What is it by the time we get to that 5th place? Throw more zeros. So that's
Thousandths?
That's thousandths.
10,000?
10,000ths.
100,000?
That's the 100,000th place. Okay, so that's where that goes there.
This is super surprise guy.
Okay, easy there. Easy.
It's the scream.
Look at it.
It's the stick person version of
Now we're going from movies to classic art with the screamer. Or Macaulay Culkin, Home Alone. Ah! So
no,
see, I can get ridiculous too.
Now emoticons.
Okay, all right, chill. All right, chill. Let's get back to business. Which ones they want to know about? Okay, they want to know in this one. Okay, what's in the 100th place? Which one's in the 100th place?
Why is there a paint?
So what digit's in the 100th place?
The 4.
Right, 100 stops here, so that would be the 4. And then wants to know what digit is in the 10,000th place.
The 5.
Wait, read it again. The 10,000th place.
9. Oops.
Yeah, count out to the to where 10,000 stops. That would be this 0, which means that's the 9 position. Okay, so and it goes on from there. All right, so you see how that plays out. So hopefully that explains place value a little better to you guys, because that's having that knowledge. And believe me, I know a lot of high schoolers that screw that up or whatever, but it's very important to get an idea on those things, because that helps you with rounding. It helps you with multiplications, additions, especially, and all those kind of things like that. So yeah, definitely, if you got to brush up on your knowledge, there's a great thing right there to be able to help you out with that. So hopefully that worked in your favor there and stuff like that. All right. So we did that. So we got some high end stuff. We got some upper elementary stuff here. We get more things in between and stuff like that. What happened? No. Come on.
I'm embarrassed.
No, it's nothing. Don't get yourself crazy about that. You're fine. So, all right. So let's see. All right. So, trying to think, what else have you been working on recently? Well, yeah, you just got done doing your division test from the stuff we talked about on Friday's stream. You just did that, and you did very good on it, right? What did you say you got? What was it, 39 out of 40? It was
Okay,
so you got a 97.5% basically.
One of them had 9 questions, and I got 8 out of 9, and the other one somehow had 40 questions disguised as 20.
And you got 39 right.
Yeah. What percentage? So in total there were 49 questions.
Here, right. Let's see. I'm sorry. I gotta erase them because I need the space.
You can erase super surprise guy, but not.
Oh,
don't erase Brock and rats, which is spelled in all caps R space A space T. No, that's wrong. That's the wrong rat.
39.
Never mind.
Okay, while we're on the subject of the decimals there. Okay, 39 out of 40.
No, its name is Ratatouille.
No.
Its name is Ratatouille, not the Ratatouille from the movie. Just Ratatouille.
Don't do that.
Ratatouille.
Can we move on?
Okay.
All right. 39 out of 40. Okay, so you can't divide 40 into 39 cleanly, so we have to have a 0 there, but we got to include a decimal.
No wait, it's 48. No wait, 40. No wait.
You said 39 out of 40.
No wait, in total, the questions I answered, I did.
Wait, I'm just talking about this
49.
one. Okay, all right, here. We'll do that one in a minute. I want to do this one because I want to do this one a little bit first because it's neater. All right, she insists. All right, okay, I'll change the question.
There were
49 questions, and you got 47 out of them. Okay, well, either way, we're still in the same boat as to where we are. Okay, so I'm doing it right here. Okay, so we can't do 49 into 47, so that's 0. So that's why we have to bring in the decimal there. Okay, but now treat this like 400. But now treat this like 470. So the question is, how many 49s can we get out of 470? Likelihood says in this one, because of how close 47 is to 49 to begin with, I'm going to probably imagine we can get 9. Okay, so let's see. So we need 49 times 9. 9 times 9?
9 times 9 is 81.
81, carry the 8, so 9 times 4 plus the 8. Voice it out. Voice it out. Let them hear you.
36.
36, yeah, plus the 8. That one's out too. Don't do that.
Oh no. 36.
I know it's 40 something. 44. Okay, so all right, do the subtraction. Okay, so get that there. All right, so 29 left. Okay, so we go to the next decimal place, bring down another 0. So let's see, how many 49s can we get out of 290?
5?
I'm pretty sure 5 is going to be it. Let's see, because 9 times 5.
45.
Okay, 5 times 4 plus the carryover 4.
24.
Okay, and yeah, we're left with 45, so that's where that plays out. Okay, and then so you can see it's about 95%. Okay, but then here comes another one. Okay, and we know this is going to be 9 again because we did 9 and got 441 before. So, and it goes on from there. It's probably not going to give you anything. It's not going to come out to a decimal that stops, so it'll just go on forever. But this is close up. All right, so here's the thing that wait, but this is important to us. Here, let's get back talking about what we said with place value a minute ago. So you've got this.
I got a 95%.
Wait, hold on.
So I got a 95.
Okay, wait. All right, so hold on.
That's sticker
worthy. No. Hold on a second. Wait. Listen here. I know where you're getting the 95 from, because then how do you translate this to a decimal? We talked about it before.
Oh, 97.
Wait.
Because you round it.
Okay, let's talk about the rounding discussion for a second, okay? And we'll look at this both ways. We'll look at it as round the decimal as it is now and then turn it into a percent, but then we'll look at it the other way where we turn into a percent first and then rounds. We'll get the same answer regardless, though. So follow this. If we round it as it is now, what we have to recognize that 100% represents one whole, which would read like this: a 1 with 2 zeros. So we have to recognize that, again, following that 100, that this is, for what we just talked about with place value, this is the hundredths place. So if I round this number, if I round 0.959, round it to the nearest hundredth, that means here is your cutoff. So the decimal has to stop here. You look as you've done with other roundings, you look at this number right after it. So with a 9 after it, does that cause an up or a down? That causes an up rounding. So the 5 therefore graduates to a 6, and you have that. And then now with 2 decimal places, you can properly translate it to a percentage value and get 96%, like that. Now you can do it that way. The other way you could do it, hold on, wait a minute. Now the other way you could do it, Brianna, what if you turned it into a percentage first? Okay, follow this.
Oh.
What if you turned it into a percentage first? Okay?
I don't know how that works.
Okay, well, here's what I want you to see. Look, notice that when you take the real number, Brianna, and you turn it into a percent, the decimal point goes 2 places to the right in order to create the 100. Okay? Okay? Gotcha. Okay, now, so look at it that way. Okay, so you move it 2 places to the right in order to turn into the percentage, because this tells you how many parts out of 100 that you've got. So do the same thing to this. Move this decimal. So come back to this number now. Move this 2 places to the right, Brianna. And what would the percentage say? Move this decimal point 2 spots to the right. What number would it read? Well, wait. Once you move it over, that 0 is not going to be there anymore. Oh, okay, I see what you're doing. Right, it would be like that, 95.9%. So what happens now is, okay, you would round to the nearest, yeah. In percentage form, you would now be rounding to the nearest whole percent. Which again, the 9 that follows it would cause a round up. It would graduate the 5 to a 6. So you still ends up with to the nearest whole percentage, about 96% regardless. Okay, so that's the nature of.
Do you know this one?
No.
Got him. That's an awesome face.
Okay, I did that sort of unintentionally because of the nature of that I did the 2 over, and I just saw the the goofy face that could result from that and stuff like that. Puppy face.
Puppy face.
Puppy face. Arf arf. Yes, exactly.
Sally face.
This is how we entertain ourselves, folks. Hope you like it too.
Sally.
Got it there. Okay,
Bubble Sally.
so that's the nature there. All right, so we got some divisions with involving decimals. We talked about the rounding. We got place value. We got a lot of stuff in here on decimals, and I'm probably sure. And I'm probably sure as she's going through some more stuff relating to decimals in the near future, we're probably going to see some more things in this discussion. Maybe see a revisit of some of these things. So I hope you come back if you're having trouble with decimals to be able to see those things happening along the way, and we'll pick up from there hopefully next time. But I'll tell you what, I know we try to go at least an hour, but we're getting close to the hour anyway, and I want to see what's going on with. Stop that.
We're ending early?
Well, I want to figure out why
Can I show the rat?
No, do not.
Aww.
You showed the rat. Okay.
No, but the rat.
No.
How come?
Stop. That's not for now.
You can look at it on my. I don't want to.
You're silly. But I want to see what's wrong with this because this has been very wacky, and I hope you've been able to still see clearly in spite of everything going on what we've been doing with the math here. I'll try to figure out for Friday what's going on here with the camera so we could see it, and I'll send the information along to some people so they could if they've got an example of what the heck's going on. All right, but in the meantime, we're gonna check out
sad, so then they have some nice ratty fun.
Okay, fine, whatever. All right.
Oh gosh, it's really going on the fritz.
No, that's what I mean. I've really got to check this out. So we're gonna end it here. Hopefully, though, you still were able to see what we were doing. Hopefully, you enjoyed it, and again, appreciate our silliness as we got through all the material and stuff like that. In the meantime, if you enjoyed this video, no matter how it is that you're seeing it, bang, bang, bang. I'm not even hitting it, so the fact that it was going extra garbled like that, just please give a thumbs up to this video. Please like, share. I always use a tree diagram when solving accounting. So we do have time for time. I always use a tree diagram when I'm solving accounting problems involving permutations and combinations. Or can you always use a tree diagram? Counting problem.
What's the tree diagram? Is it this?
I'm thinking no. Okay, no, wait.
I gotta draw a decent tree.
Stop, you silly. Okay, wait. Tree diagram. Because when I think of a tree diagram, I'm thinking in terms of a factor tree. Okay, I'm thinking in terms of a factor tree. Like if you're breaking up the number 120, for instance, I'm thinking of it in terms like this. I'm thinking of 6 and like figuring out what
diagram inside a tree.
You stay with me. I'm thinking of a tree in this fashion.
Oh, yeah.
Thinking of what factors out to make a number. Like 120 would be, for instance, 6 times 20. Okay. 6 is a 3 times 2. 20, you got a 10 times 2. And then that's a 5 times 2 and stuff like that. And we just bring everything down so we can see everything on level. That's what I'm thinking of in terms of a tree. I'm not entirely sure what you're what you're saying about with a combination and permutation,
That's
or like
fourth
say,
grade
I
me.
mean, if I see it, I mean,
That's look,
if I
that's
see,
me
here,
in
wait, pass
fourth
me
grade.
my phone for a second. Pass me my phone.
Okay.
Pass me my phone.
Look, that's me in fourth grade.
Wait, can you use this for combinations and permutations? Hold on a second, because usually I normally have not associated doing this with combinations and permutations here. Let me see something.
What's the lightning alarm going
Combinations tree diagram. Okay, let me see what you're talking about here, because maybe perhaps there's something that I am not aware of. Oh, okay. I see what you're talking about. I gotcha.
on?
Okay. No, you know what it is? No, it's okay. Counting principle and stuff like that. Yeah, you could do this. You could do this kind of thing. But I'll give you a short way. I'll give you a short way of trying to simplify the whole process for yourself. Okay. What the tree diagram does in a counting principle problem is it will like map out for you all of the different possibilities as to what things you could group together. Well, here, follow this. So I know what he's talking about now. So here's the example. Let's suppose Brianna. Okay, let's say you were choosing your like what your outfit was for today and stuff like that.
Animal Crossing.
Okay. No. Just in what you're wearing right now. Okay. So like Brianna right now, she's got on a t-shirt, she's got on stretchy pants, and she's got a hoodie on over that.
My favorite hoodie, because it has a unicorn on it.
Okay, so let's suppose that she had three hoodies to pick from today. Let's say she had 2 t-shirts. Okay, and she had
I think
she had 2 stretchy pants. Okay, so like that. So what you're asking?
I did have 3 hoodies I could choose. Oh my
So what
gosh,
you're asking
right.
about? Okay, all right. Well, here. So what you're asking about in the tree diagram, Cam, if you can see this is okay. What the tree diagram would do is okay. So you're starting from here. So the idea is that since Brianna would have 3 hoodies to pick from, that means okay, we could start a tree branch here where we list out her available choices of which hoodie she could pick. So if she has well, let's go by colors, for instance, whoever. Okay, so you got gray hoodie here. Let's say you have a white hoodie here.
No, a black hoodie.
Okay, fine, a black hoodie.
And then mint hoodie.
Picky.
But it's true.
And then a mint colored hoodie. Okay, so that's what she has for there.
That's actually true.
Now, the 2 t-shirts that she has available. Okay, she's got a gray one on right now. And what other shirt were you thinking about wearing today? What color was it? That you could think of?
Purple.
Purple? Okay. So she had a choice of whether she was going to wear a gray tee or a purple tee. So the idea is that from each of those 3, the way the tree would show it, you would branch out to indicate.
Oh, it's one of those
to map out those. And then the same thing for the pants. Okay, so she's wearing black stretchy pants right now. What else might you have chosen today?
Gray.
Okay, all right, so gray again. Okay.
I don't know.
So the same thing. The black pants and the gray pants would go through there. Now, by the time you get down to the ends here, the idea of choosing one from all of these, the question is, how many outfits can you make by choosing one thing from each item?
You want to know what this diagram kind of reminds me of?
Within a tree diagram, well, here, let me just get to the end of this 1 second. So by the time you get to the bottom of the tree diagram, the idea is, well, to represent pants.
Oh.
H is hoodie, T is t-shirt, P is pants. All the other things above it are the colors. But here's the thing. Count how many branches you've got here at the end of when the whole tree is done. So count your way across. How many total branches did we finish with on the
3,
tree?
6, 9, 12.
Okay, you counted a little differently than I would. Since we had 2 at the end, I was going to say 2, 4, 6, 8, 10, but still 12. We were able to come up with 12 outfits. So that's how it works there. Now that's how you look at it when you're seeing it in the perspective of a tree. Okay, but that will map out all the individual.
This isn't a tree yet.
But that's not. Oh, come on.
Now it's a tree.
An upside down tree because this is the trunk.
No, this is.
No. What tree do you know of where the branches start extending from the very top of the tree down?
Huh?
I'll show you later.
No, this is inside. Of the tree.
You still lost where I was going with it. You still. Hopefully you see it.
No,
okay.
Like the
okay, but getting back on point.
Oh,
here, I'll show you later. I'll show you later what you're doing wrong. Okay.
But this kind of reminds me of one of those like it doesn't like describe one of those perfectly. It's like one of those choose your own adventure thingies on Netflix.
Yeah, there's multiple roads that you could enter. But that
like
okay, but that wouldn't
but
understand.
The same thing, but certain paths can like really like.
Yeah, okay, but that doesn't totally play out the same way.
Just like reminds me of that.
Because in a situation like that, when you choose the one option, the next choice you have available to you won't necessarily be the same after when you pick choice A versus when you pick choice B.
Like,
you know what I mean? Here the whole
wait,
Brianna.
Of like
Brianna,
how the paths can connect.
I know, but that's not this. That's not this.
Can I please just give an example?
That's Brianna.
It's like the new
Brianna.
San Diego. Sorry. Okay.
That's not this. The reason why it's not that is because unless when you go to your second choice, when you have to make your second decision, if the options for that second decision are not exactly the same are not exactly the same regardless of what you did on decision A, then it doesn't fit this problem model. And having it where the results are where two different pairs of decisions could lead to the same ending, that doesn't fit this model either.
I know, but it just like kind of reminds me of it.
I get what you're saying, but yeah, no, it wouldn't fit that. Okay, but can we get back to the point? Somebody is waiting for us. Okay.
It's not even Wednesday.
You're deviating now. Okay, too much.
It's like that new.
We ended up with what? Brianna.
Sorry. It's true. Like the mark.
Can I get back to the math?
Sorry.
The 12 outfits that we came up with here at the ends of the thing. Sorry for waiting. Here's a fast. So these branches give you all the possible outfits that you can make, from a black hoodie and a gray tee and black pants to a mint hoodie, gray tee. Purple tee, and gray pants, and everything in between. But here's another way you could use those numbers to get to that same 12, just to get the number of items here. And it's what's called the counting principle. And I know we've done this before in the, I think we did this in one of the early live streams, the counting principle. Basically, these three groups that you have there, just take those and just multiply them together. And it'll give you that same 12. 3 times 2 would give you 6, and it'll make sense because if you look at the second level, you have 1, 2, 3, 4, 5, 6 possibilities laid out and stuff like that, times the 2 pants, and 6 became 12 like it did at the bottom. So just that simple option, that simple set of multiplications will tell you how many different ways you could perform the task by taking one item from each group. And the tree will spell out all of those possibilities. So can you do it? Yes. It's just a matter of being able to just recognize along the way that And I lost my sentence there. Okay, but did that make sense to you? In spite of all the ad-libbing and off topic that we got, did this hopefully make sense to you? How we got that? This spells out all the possibilities, but this very quickly, just fast, tells you how many possibilities you should expect. So I hope that makes sense there. All right. So okay, yes, okay, good. I thank you for that. All right. Well, I'll tell you what. I got to cut business here because, like I was saying right before you jumped in, I got to figure out why my camera is being screwy on me or whatever, and hopefully I'll have it fixed and proper for Friday and so. Right, but wouldn't it be difficult to use a tree when dealing with that? Yeah, in terms of listing out possibilities, absolutely. Yes, it would definitely be difficult to list it all out. So yeah, so you gotta definitely understand that yeah, you want, I mean, yeah, it's a lot easier, yeah, come up with the number of possibilities and things like that first. That you can definitely do no matter what, okay, regardless of what the numbers are. Because so like, let's say that if instead of that, what if Brianna was still picking from 3 hoodies, but let's say instead of only 2 shirts, let's say she had 6 different t-shirts she was considering wearing today, and one of 5 different sets of pants or whatever. So yeah, multiply those 3 times 6 times 5. And here, Brianna, help me out with that. Here, let's 6 times 5. We can get that one fast. 630 times the 3. 90. So yeah. So then you would have 90 different outfits that you would be able to make. But yeah, doing a tree, mapping out all 90 possibilities, yeah, that might take a while. And yeah, it would be very space consuming. We see how space consuming doing this is already in the first place. Imagine if you had 90 branches down at the bottom. Yeah, it would be tough or whatever. Still correct, just long and involved. So I think Cam, what you're asking for really in essence is the fuss really is more about calculating the number as opposed to individually mapping them all out. And the calculation of the number is based on this. Okay, being able to say, oh, okay, you have how many choices the first time out times how many choices the second for your second decision times how many choices for your third decision, et cetera, et cetera, et cetera. So look at it from the calculation perspective, okay, and not so much strictly from this. If you're asked to map out all the possibilities, then yeah, by all means you could do a tree that way and it would be fine. Or if you could come up with some sort of shortened code for the possibilities, do that too. Where like for instance in this we could say black hoodie, gray tee, black pants. Okay, that would be the BGB down there, and at the other end, you have the mint hoodie, the purple tee, and the gray pants, miles per gallon, and all the other possibilities spelled out in between and stuff like that. Okay, but save this business, whether in a listed form like this or in a tree diagram. Save that for when you're actually physically being asked to spell out all the individual outcomes that you could get. For unless they're doing that, worry about the counting principle calculation and getting that number. Okay, so I hope it is that works there. All right, so glad you were able to come, Cam. I hope you'll come back on Friday for more stuff if you have any more questions, and the rest of you out there in the YouTube audience and wherever it is you're watching us, please come back and watch it then too. All right, we'll hope to see you once again. In the meantime, as we said, if you enjoyed what we did, please give a thumbs up to this video, hit that subscribe button so you could stay tuned for when the next live streams are coming up. I've already set the programming notes for the next 3 live streams covering this Friday and both of next week's as we get into May. Can you believe next Friday is going to be May 1st already? Holy cow! We've been here over a month now. Well, look, this is week 6 of the quarantine, but
wait, Friday is May 1st.
Next Friday is May 1st. So yeah, time flies when you're stuck at home, isn't it? But anyway, keep coming back. Let us help you with everything that you're doing, and as you've seen, just let our silly minds entertain you and distract you and stuff like that while we're educating you, and we'll just have a good time with it. And all right, and just make a note for next time, Brianna. And I'm saying this on camera so everybody pays it. No, you're fine. Get over here. Hugs, 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 hugs. Come on, get over here. Okay. She just gets a little carried away, right, folks?
I
All
like
right?
Carmen Sandiego.
No, for anything. You just get on your mode and you just can't get off it or whatever. Okay, just bring it back for me. Okay. All right. We'll see you Friday, guys. Take care. So long.
Bye.
Will you get your hand away from the camera? Bye. See you, Cam.